Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face Trending List, published on October 30th, 2025, just yesterday. The big result is that this paper beats full softmax attention across short and long contexts in reinforcement learning, while cutting key-value cache usage by up to 75% and reaching up to 6 times decoding throughput for a 1 million context. The paper is titled Kimi Linear, an expressive, efficient attention architecture. And as we dig in, the implications for long context efficiency and model quality are quite significant. Also, the authors shared a GitHub repo. You'll find the Kimi Delta Attention kernel with the hybrid linear attention implementation, a tech report and figures, 48B model checkpoints, quick start inference code using transformers, and VLLM deployment commands, along with the minimal setup requirements to run everything. Alright. Figure 1 shows that the hybrid design delivers stronger quality while keeping decoding fast. The left panel plots performance against decoding acceleration, and it places the approach on the best trade-off frontier because it scores higher while being about 4 times faster. The right panel charts time per output token, which means the milliseconds needed to emit 1 token during generation. The blue curve stays low across growing lengths, yielding roughly 6 times faster decoding at 1 million tokens. So, Figure 1 showed quality and speed. Figure 2 compares kernel execution time across input lengths. Here, kernel means the low-level operator that performs the attention math. The blue KDA curve stays below the dashed DPLR curve and rises more gently, which signals faster and more scalable kernels. The setup uses batch size 1 and 16 heads. This gap underpins the roughly doubled operator efficiency the authors report, especially as sequences grow. Alright. Figure 3 lays out the model blueprint, showing how token mixing and channel mixing fit together for both speed and quality. The left column stacks blocks where Kimi Delta Attention dominates, occasionally interleaved with multi-head latent attention to capture global links. The upper right panel sketches the mixture of experts router, which sends tokens to a few specialists to save compute. The lower right panel details the Kimi Delta Attention path with short comms, L2 norm, and data-dependent gating. Table 1 compares design choices and shows which settings lower perplexity, which is a measure of prediction uncertainty where lower is better. The best hybrid uses a 3-layer KDA group. Each group is followed by 1 MLA layer. It reaches a training perplexity near 9.2. The validation perplexity is about 5.7, and settings without the sigmoid output gate, or without the light convolution, hurt generalization, because they remove useful control and local context cues. Wrapping up, 2 takeaways stand out. The hybrid Kimi Linear architecture with Kimi Delta Attention matches or beats full attention while slashing memory and delivering up to 6 times faster long context decoding. And the open kernels and checkpoints make it practical today. That unlocks longer inputs, cheaper serving, and quicker reinforcement learning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.